Welcome back to the Foundation in C# course. We are currently in Module 8, and this lesson we're going to be covering Entity Framework, specifically Entity Framework Core 3.0. So this is the latest and greatest as of the time of this recording, and it also has some significant performance improvements. Actually, up until this point, I have never taught Entity Framework as a solution. And part of the reason for that is because up until now, there have been a lot of really big downsides to Entity Framework. There's been some major improvements. I'm not going to say that this is my ORM of choice, because Entity Framework is an ORM, or an Object Relational Mapper, but it's a much more heavy ORM than Dapper is. So this isn't necessarily my framework of choice, but I do want to show you as a viable alternative for certain circumstances. So let's go through what is Entity Framework, how does it work, and what are the upsides and what are the downsides of using it. Okay? So let's go to Visual Studio, and in here we'll create a new project, and let's create a console project, something really simple. And we're going to call this our EF console UI, and we'll call this EF solution, for EF for Entity Framework. Okay, and the first thing we'll do is we will get rid of this console write line. We'll add our console read line at the end, and before that we'll put our console write line that says our email model first. So email, and yes, I named it email, not email model. And we're going to have ID, and we'll have a string for email address. Okay, and then we'll have another one for phone. And yes, again, no model. I'm going to explain why in just a minute. So ID and phone number. Okay, and now we have those two, we can create a contact model. So contact, make it public, and we'll have an ID, and we'll have a first name, and we'll have a last name, and we'll have a list of They don't want to create SQL queries, okay? And so they want to do that with their C# tooling. That is most easily accomplished by using code first Entity Framework, because Entity Framework will create the database, it will create the queries, will create the tables for you. We'll be using code first. So this contact will become a table. So will email and phone. This more closely aligns with the SQL naming convention where a table will be called contact, not contact model. Okay? We don't call tables contact model. We call them contact or contacts. But we don't want to make it plural because this model is a singular item, whereas a list of that model would be plural. So it gets a little messy with the naming conventions, but we're going to try and follow a pretty standard naming convention pattern here. So I'm going to call mine contact, email, and phone number. Next, I need to add some support for my entity framework. So manage NuGet packages, and we're going to install the SQL Server. We need to install tools. So entity framework core.tools. And this will allow us to scaffold things out, do things like add migration, drop database, get context, update database, and so on. So we'll install that. So that's our tooling for working with entity framework. The final one we need is one we've done before, which is the Microsoft.extensions.configuration.json. We're in a console application. We need to talk to appsettings.json, which isn't set up yet, but we're going to need to do that. Okay, let's close these down, and we will add that appsettings.json while we're thinking about it. So new item, JSON, JSON file, app settings. We'll add a connection string here. Connection strings, and we'll say default. And we need a connection string for this. Now, the way Entity Framework Code First operates is that you create the connection string to a database that's not there yet. And Entity Framework, one of the things it will do is create that database. So we need to create a connection string, but we don't have the information quite yet. So let's go to connectionstrings.com and let's scroll down to SQL Server. And we're going to choose a trusted connection. So this is a trusted connection connection string. Okay, I'm going to copy that. I'm going to paste it in here and we're going to modify it. So first of all, the server address. Well, we're going to install it into our local DB. So notice here it says local DB in parens /ms I'm going to create a new folder. I'm going to call it data access. I'm not going to create a whole nother project, a class library. And this is something that bothers me about Entity Framework is it really encourages you to pull your data access up higher and higher into your user interface. I'm not a big fan of that. I want to keep my data access separate. So I'm going to model it as if it's separate, even though it's in the same project for simplicity. But I just don't like it here. In fact, I'm debating maybe I should just create the class library anyways, just to make sure it's very, very clear. Don't put your data access in your user interface. I think that I'm not going to do that. Okay, I'm not going to do that for a couple of reasons. One of which is that I'm really encouraged by Entity Framework to put this layer up higher. But two is it's going to make it a little clearer, I think, not to have that separation. But this is one of those pushbacks that I give a lot, is this mixing of layers. So data access, and in here we're going to create a class. And in this class, we're going to call this our contact context. Okay? And you can really call this anything you want. I'm saying that our database kind of surrounds contacts. I know we called it, maybe I should change this database name. Let's call this EF contact DB, which I don't believe there's no EF contact DB either. That's a little more clear. So let's make this public class contact context. And we're going to inherit from DB context, control dot to add our using statement there. And what this does is this is the application that configures Entity Framework. This is our kind of our glue that we use to connect everything up. So the context is very important. The first thing I'm going to do is have a protected override on the protected override void on the on configuring method. So on configuring, and in here we'll pass in DB context options builder. We'll call it options. So this is an override, meaning it's in DB context, but we're going to override it. Okay? Not configuring. How about that? There we go. So I'm not sure why it didn't pop up. Typically you see it'll pop up when you do a protected override. It'll say, okay, here's the ones you can override. It didn't do that for DB context. I'm not sure why. In any event, I know that's there. It's a method in DB context. We can actually see if we go to F12 and find it. It should be in this list, I believe. If not, then it's actually a couple higher. It's in here somewhere. But what we're going to do in here is this is where we're going to set up our options for Entity Framework. And the only option you really want to set up is to use SQL Server. So option.use SQL Server. We have to pass in a connection string, which we don't have yet. Okay. Now, the reason I have this use SQL Server available is because I added this NuGet package, Entity Framework Core.SQL Server. Now, if you go looking for Microsoft .entity framework core dot like so, you're going to see not just SQL Server, but you're also going to see things like in memory or SQLite, and there's SQLite.core. dot get current directory, and then add JSON file. We're going to add the JSON file for app settings.json. So it's going to look up and create a configuration builder for talking to app settings.json. And then we'll say var config equals builder.build. Just like before in all of our other console applications. Now here, we can say config.getConnectionString for default. And that will get our default connection string. Okay? So now we have our context set up. And this is kind of like the quarterback that sets up or talks to and configures Entity Framework. But we're not quite done here yet. We've got it talking to SQL Server. We've got talking to which server we want, which doesn't exist yet, but it could connect to it once we have the database. But we still need to set up what models we're going to use. And a model represents a table in SQL Server. So we got 3 of them: contact, email, and phone. So public db set of type contact. Control dot for our using statement here. Let's call it contacts. And this is a property, so it's get and a set. I forgot to do the prop. So there we go. db set for type email. And we'll call this email addresses. We hit enter, and it's going to create a migration script for us. Done. Okay, now we've created a migration script. Well, that opened up a script. Let's look at, we've got a new folder here where we have context model snapshot. There's a snapshot for us, some generated code, about 96 lines. Then we have this create database.cs, which has an up and it has a down. All right. So the benefit of Entity Framework is that when you script out a database creation or table creations or table modifications or something to that effect, it creates an up script and a down script. And the up script is, notice it's going to create the table contacts. And it's going to create the table email addresses. And it's going to create the table phone numbers. and then it's going to create a couple of indexes. That's what it's going to do if you run this script and go up to this level. If you decide to roll back, it's going to there. That's the arrow function. So it says, okay, we're going to create this, which is a new object, which it's going to have an ID, a first name, and a last name. The ID is a table column of type int that is not nullable, that is a SQL Server identity column with a 1, 1, meaning it's going to start at number 1, it's going to count up for every row. That's our auto-incrementing value. Then the first name, which is a table column of type string, and it is nullable, meaning you can insert a null value. We'll come back to that in a minute because that's not ideal, because now you can have a null first name. So you can have blank Corey. Well, that's not ideal. But we'll come back to that. So those are the columns. We also have constraints. So we have a primary key. That's a constraint. Here's the name of the primary key, and it's going to apply to the ID column. Now, because we named our column ID, Entity Framework says, okay, that's a keyword. I know that's most likely going to be the primary key. Therefore, I will mark it as such. Okay, so it is doing a little bit of name inference. So based on what we name things, it's going to infer which ones are IDs. So that's the contacts table. Now we have the email address table. Same kind of thing, where it is an identity specification for our primary key of ID. We have an email address, which is a nullable string column. We also have this contact ID column, which is an int. But we never put a contact ID in our email. No, we didn't, but in our contacts table, we said that we're going to have a list of email addresses. So it's got to be some way to link those together. So that's a contact ID. That's going to link back to the contacts table in this ID, which does follow the pattern that I showed you in SQL Server, where when it's a foreign key, we try and name it after the table that it's referencing. So contact ID references the ID in the contact table. Okay? Also note, this is called contacts, plural. Email addresses, this is the more impressive one, ES. Okay? And down below we have phone numbers. But yet we have contact, email, and phone. Well, it's picking that up based upon what we called it in the contacts table. We called it email addresses, and we called it phone numbers. Okay, so in the contact class, we said email addresses and phone numbers. So it's picking it up right out of there. That's pretty impressive. Now, we also have the email addresses table, a constraint, not just a primary key, which we do, but also a foreign key. Remember I said I didn't set up foreign keys in the SQL database, but we could have, so that we'd have a cascade delete possibly, or other options. Well, that's what this is doing here. So we have a foreign key relationship to the contacts table, and it's linking the contact ID. So we're going to link to the contact ID. We're going to link to the ID in the contacts table. Okay? And then on delete, we have these options. Notice restrict. There's also cascade, set default, set null, no action. So this would not perform the action of deleting the record it would not perform the action of deleting a contact if there was a linked email address. That's what that restrict does. Okay? That's the option they chose. Again, I have told you, I'm not a big fan of deleting records. I'd much rather see you archive them because of all those references you have to deal with in some way. But I just want to show you that as how it was designed. Okay, so phone numbers, same kind of thing, and they also have indexes. So the email address is indexed on the contact ID column, and the phone numbers is also indexed on the contact ID column. So that's all the setup that created in code that will then apply to a SQL Server database. Now behind the scenes, there's also more code, okay, where it's got a little more specification of how it's going about some of these tasks. So for example, the first name is going to be an nvarchar max, and so is last name, max, which means it can have thousands of characters for our last name. Not what I want. We're going to come back and address that. Okay? And so there's a little bit more information in here about the specifications. Now, this migrations right here is one of those things that people often ignore and say, that's just entity framework code. I don't have to worry about it because it's been generated. And that is not true. Entity Framework does a best effort at writing the code you need. However, at the end of the day, if there's any kind of problem, you're the one that has to maintain it. It's not like you can call Microsoft up and say, your code is doing something weird, can you fix your code? Because this generated code is now part of your application. It's part of your source code base. So you have to maintain it. So if the configuration did something weird, or did something you didn't expect, or did something that's less than optimal, like that nvarchar max, that's on you to fix. And that's another reason why I've not been a big fan of Entity Framework. It's not because it's not a great tool. It is an amazing tool. Entity Framework is incredible for what it does. However, its power is often put into the hands of people who don't know how to use it. Okay? It's like having a massive earth-moving machine. It can do great things, but you wouldn't put an intern in the cab and say, go for it. Because you can easily mess things up. You can easily cause problems. And so it really does take an intermediate or advanced level of C# knowledge before you're ready to maintain these migration scripts and these contexts and manage these models. Because as we'll see, you can't just write a model and be done. You have to tweak the model. Then you have to know how to look at SQL and do a SQL profile to see if your queries are doing what you expect them to. There's a lot of work that goes on behind the scenes, or needs to. A lot of people don't do that work because it just works in development. Therefore, it must be easy. And it can be easy at first, but if you don't put the time in, if you don't understand it, it will burn you down the road. And that's my biggest problem, is it's too easy to get into Entity Framework, where it's easy to then work yourself into a corner and really cause major headaches for yourself. And I don't want that for you. I want you to be able to feel confident and not feel like you're dealing with magic. I really dislike magic. You've heard me say that before. I'm really against magic, where things just happen magically. Because when the magic breaks, you're the one left holding the bag. I don't want that for you. So I'm going to try and talk you through this and walk you through this. And there's a reason why I'm taking so much time with this and being slow about this, is because if you go fast with this and just get it to work, and it will work really quickly, then you're going to miss how to maintain it. And when you put this into production, you'll almost inevitably have a problem once in production that's going to make you pull your hair out. Okay, so we've reviewed the first migration script. I'm not happy with it, but I want to push it to production to show you some of the reasons why I'm not happy with it. And then we're going to work with it anyway, and then we're going to make modifications to make it better. Okay? So what we're going to do is go back to our package management console, and we're going to type one more command. So we've added the migration, and that was this migration right here, create database. That's the first. B. Then we're going to set the server property for database engine, set read committed snapshot, and then we're going to start by creating a table, which is the EF migration history. So this is an extra table that Entity Framework creates. And then we're going to come down here and once we have applied the migration, then we're going to create the contact table. There's the contact table script. Then here's a script for email table. Here's the script for phone number table. Then we have create index, and then we're going to insert into the migration history the values of what we did and when we did it. Okay, so we've said that we've done the create database migration. And the reason why is because if we run this update database again, it's going to tell us we're up to date because we don't want to apply the same update again. We don't want to try and create those tables over again. So it's going to make sure that migration history, it's going to say the last migration I ran was create database. So if you have more migrations since then, let's say you have 2 more or 3 more, cool. I'm not going to run create database, but I'll run all the ones after that one at a time. Okay, so that's what happened. Now we can go to SQL Server Object Explorer. We can refresh these databases, and we'll see that we have EF Contact DB. In here we have our EF migration history. We have contacts, email addresses, and phone numbers. Inside contacts and the keys, columns, we have a primary key, we have a first name and a last name. Both of those are nvarchar max, not ideal. Email address, column, primary key is ID. Then we have email address, which is nvarchar max. Again, not ideal. Also, it's nullable, just like first and last name. So you could have an email address with no actual email address. Not ideal. And we have that contact ID, which is a foreign that, because that way you can start adding to them right away. All right, oops, forgot my semicolon. Okay, so now I can, and we've done this a couple times already, a number of times. So c.emailaddresses.add, and we'll say tim@iamtimcorey.com. And I'll copy that and paste it, and this time it's going to be me@timothycorey.com. And oops, I can't do that. Let's cut that out. New email where email address equals tim@iamtimcorey.com. That's better. Let's copy and paste this and just modify this again. Always pay attention to your red squigglies. Okay, so now you have two email addresses. Now we're going to have phone number. We're going to have phone number equals 555-1212. And we'll do the same thing again. This time 555-1234. Okay, so now I have a new contact. What do I do with this contact? Well, I'm going to say using var db equals new contact context. So that's this class right here. Remember I said this is the controller. This is the thing that identifies and configures Entity Framework. We're going to tap into that and create a new instance of it called DB. And I can say db.contacts, okay, which I specified that right here. Contacts, email addresses, and phone numbers. Okay, and so now I can say contacts dot add C. Okay, so I just add a new contact that's created to my contacts DB set. Now I can say db dot save changes. Now what did I just do? Well, I established a connection to an instance of the contact context, which is what controls Entity Framework. I said, give me the contacts table, and I want you to add a contact to it. Now I want you to save those changes. And when you do save changes, it's going to write out to SQL. But here's the really cool thing. I didn't actually just write to the contacts table because, yes, first name and last name goes to the contact table. But email addresses go to the email address table and they link to the contact table. Phone numbers go to the phone numbers table and they link back to the contact. Okay, so that's what's happening here. All right, let's run this. Let's create one more before we do. It'll make it a little more visual, and I'm going to show you in the code as well. So let's do a read all. So private static void read all. This is where we're going to read everything from the database. So using var db equals new contact context. And by doing this in a using statement, it gets disposed right here, which means we leave our database connection open for as short a time as possible. So don't leave this open indefinitely. You don't want to leave connections to your server open. So now we're going to do a read. And we're going to say var records equals db.contacts. And I could just do just that. Now I'm going to say to list, which I have to control dot to add a system.link. And what this will do is, if I just used contacts, what it's going to do is it's going to say, okay, that's what I want from the server, but wait, don't actually get it yet. Wait until you figure out what Tim really wants. because that way it can do as much as it possible on the server side with querying. You don't want to pull down everything to your local machine usually. Now in this case we do because we actually want all the contacts. But you don't always. So Entity Framework really tries hard to wait until the last possible minute to run the query. That way it can figure out, is there anything I can filter this by or shrink down this list before I get to the client side. Okay? But in this case, I said to list, which means this is going to convert what is a DB set of type contact to a list of contact. What that will do is it will pull down every record. It says, okay, at this point, you have to know in C# what all those records are. Therefore, just download everything. So that's what's going to happen. Now we can do a for each and say for each C in records for contact. We can say control write line or console write line. And then we can say c.firstname space c.lastname. Okay? Just first name and last name. We're going to read through and read them all. So let's first create Tim, and then we're going to read all. So we'll create the Tim record, and then we'll read all the records in just the first name and last name. Now, I am going to put a breakpoint right here at the end, after it's read everything. You want to inspect this records list. Let's run this. First of all, see if it runs. It does not. Awesome. You know why? I forgot to set appsetting.json to be a local file. Is anyone keeping track of how many times I've forgotten this? Window, records, we have one record. Now look, we have email addresses, a count of 2. We have Tim at I am Tim Corey, and we have me at timothycorey.com. Let's expand this. We also have phone numbers, which also have 555-1234 and 555-1212. So now we have all these records. We brought them all down. Now, that's really cool and really powerful. The fact that normally in SQL, I have to write a join statement for that, and then I'd have to figure out how to create those lists, and probably be 2 or 3 SQL calls. However, nothing comes for free. Just because it works really cool in C# doesn't mean the code that it wrote is any better than what you would have written manually. Now, granted, it was so much easier to write this way and just say, include these things, and have magic happen, and just do it, versus us writing 3 queries and linking them together. Okay? Which is what we did in the SQL, SQLite, and MySQL. That's what we had to do to link those in. So it's so much easier to do it this way. But on the back end, this is still writing that complex SQL. And it may not be writing it as neatly or as intelligently as we'd like. Entity Framework, especially Entity Framework Core 3.0, is really intelligent. I am not in any way going to put that down. It is incredibly intelligent, but it's still a machine trying to make a best guess effort at your unique data. So, this is something that you have to make sure that you do some SQL profiling on. Make sure that the query that it writes is what you want it to write. You may have to rewrite your link statement to do this better. There are things you can do. For example, you can say as enumerable, like so. You can put in between, and the include won't work. I don't think. There's a couple steps you have to take in order to do it this way. But essentially what you could do is bring down those records and then include some things. Or maybe you can break it apart into 2 queries. Or there's a number of things you might have to do, because this is going to create one SQL statement. This join might be squirrely. Okay? And so you want to make sure that join is not going to blow up your SQL server trying to crunch through things. You also want to make sure that it's not bringing down a lot of duplicates of the contact table in order to have one for each email address and one for each phone number. So there's also that you have to look out for. So here's what I'm going to do. I'm going to go and show you how to do just the barest minimum of SQL profiling, just to understand what the query is that you're running. Now, this is not in any way an in-depth SQL performance tuning course, okay? So this is just to get your feet wet, just to get you started. There are definitely a lot more you can do than just this, but I want to show you something to at least get you the, let's say, 60% or 70% of the way towards knowing what's happening behind the scenes and knowing how to adjust it. And a big part of knowing how to adjust it is to know what's going on. So let's open up SQL Server Management Studio, SSMS. If you don't have this installed, it's free. You can download it. And I have, my version's a little bit out of date. I've got version 18.1. It keeps bugging me to upgrade. I keep putting it off because it's just one more thing to install, right? So I've connected to my local DB. So even though it's local DB, which was installed with Visual Studio, I can connect to it with SQL Server Management Studio. And if we open this up, we'll see that there is the EF Contact DB. But if we go to Tools, there's SQL Server Profiler, okay? And it's going to open up a separate window, which I'm going to connect to. I'm going to connect to my server. So let's get rid of SSMS, and we're going to create a new trace. Okay. We're going to connect to local DB, Windows Authentication, hit connect. I'm going to choose the T-SQL_duration option. That's the template. You can choose your own template. It's up to you. This is probably broader than I want, and it's much more shotgun than I would appreciate, but this is a quick way to get you in without having to teach you all the tooling. I'm going to hit run and let this run. Then I'm going to go over real quick and run my command line. And then what I'm going to do is I am going to stop the profile and we'll look at what it ran. Okay? So, run. It's running. I come over here and I hit run, take the breakpoint off, and it looks like it's done. So I'll hit stop, come back over here, and I'll hit stop. Okay? So my computer's not doing a lot of different calls, but that way, if I did it really quick like that, it won't have a whole lot of extra stuff. We have just this one call, SQL batch complete. This right here, let's see if we can zoom in on this a little bit. And it's a little larger than the screen, sorry. But this right here is the SQL that it ran. And the reason why is because we can have no records in the email addresses table, but still have a contact record. Okay, so this query isn't horrible. When we run this, notice that you get, and let's see if we can make this a little bigger. You get Tim Corey, Tim Corey, Tim Corey, Tim Corey, because we have duplicates, because we have multiple email addresses and phone number combinations. Okay, so we have a email and phone number combination for Tim, I am Tim Corey, and another one for Tim, I am Tim Corey, and then the same phone numbers, but now with me at timothycorey.com and so on. Now what C# does is it then takes this list and it reconstitutes it and says, okay, well, these duplicates aren't actually duplicates of the same record, so let's make one record out of that, and then these duplicates here, we have 2 and 2. That's actually 1. We'll collapse that down, and these 2 are the 2 relevant ones. The other 2 are just duplicates, and it kind of collapses everything down into nice, neat C#. But what we've done is we transfer a lot more over the wire than maybe we intended. This is a very, very small example with one person, and I transferred 4 full rows where I really needed this information, and this information with their IDs. Okay? That's all I needed. So we've transferred about 2 or 3 times the data we needed. That's not ideal. That's not optimized. And this is one of the ways where Entity Framework is going to fall down compared to you writing your own SQL. Because when you write your own SQL, what you would probably do is something a little more optimized, or at least you'd consider it. And this would be the fallback worst case, whereas this is the default for Entity Framework. Again, I am not in any way knocking Entity Framework for what this did. This is a very, very clean query that it wrote. It's really impressive. It's also really impressive it takes these 4 lines and it makes them into the model with submodels that we have. That's also really impressive. But, as you'll note, transferring maybe 2 or 3 times the amount of data across the network is 2 or 3 times more expensive when it comes to network traffic. No big deal in this case. But when you're talking about 10,000 rows, that could be a big deal. And even if your database only has 100 rows, if you have people that have multiple email addresses and multiple phone numbers and multiple addresses and that becomes exponential, the growth of your result set. So the transfer time is much, much larger. Then C# has to process and say, okay, I only want these 2 entries. I only want these 2 entries. I want this entry right here, and then combine those into models. That takes work too. So there's more work to be done on the C# side with processing more data. Okay, that's where Entity Framework gets beat up for speed issues, because it's got more transfer across the wire and more work to be done once it gets the data across, and more rows in memory than if it was doing a more efficient query. So that's just something to know about and maybe address by saying, you know what, we're not going to do it this way. We're not going to include these 2 things when all we need is a first name and last name. Because if I comment these 2 lines out, since I wasn't using those values, nothing changes in my code. But watch what happens. Let's turn the profiler back on. And what we're going to do is we're going to start this up again. And once it's done, we'll stop the profiler. Now, a few more events happened, but in here, we'll look and find our select statement. And this is our select statement. Okay? Because we didn't include those records, our select statement is just what we need. In fact, if we copy this and bring this back over, and let's just paste this SQL in here, and you run this, that's all the data that comes across the wire. Well, that compared to this is significant. So knowing what's going to come across the wire and knowing what you need makes a big difference. So if you don't need something, don't include it just because you want to have a full object. Only include what you need. Okay, so let's do the rest of our CRUD. So we've got a create, we've got a read. Let's open it back up. We're going to do another read, but this one is the read by ID. Okay, so private static void read by ID int ID. So we're going to have our using statement, using var db equals new contact context. And then in here we'll say var user equals db.contacts.where c arrow functions c.id equals id first. Okay. What does this produce? It produces one contact. Just one contact from the database. Now we can do the console write line for that contact. So see it's a user, like so. Okay. So now what this is going to do is it's going to do a where clause, but it's going to do it on the server. So let's do this. Let's do a read by ID. Read by ID, we'll pass an ID of 1. That's the only one we have. I'm going to bring back up the profiler, and we're going to start it again. And we're going to run our code. And once this is done, we'll close it out, and we will stop the profiler. Okay? Now, here's what it did. And this is where I'm not sure I'm in total agreement, but at least it's not, I want to say it's not awful, but it's not the worst thing I've ever seen. Okay? So what it's done is it said, let's run a store procedure called sp execute SQL. This is something that you should practically never use. I don't like the fact that this store procedure even exists, but because Entity Framework is a closed system, it creates its own SQL, it doesn't allow somebody else to create or inject SQL, then it's safe. I still don't like it, okay? But what it's going to do is it's going to say, I want you to run this SQL. And it says select top one, ID, first name and last name, from contacts where the ID equals this right here, and I know I want the first one, therefore only give me the first one. So it writes the SQL on the server to do that, therefore it's not going to get transferred across the wire. That's definitely optimized compared to pulling everything down and then asking for first later. That's why if you use Dapper, you'd want the Dapper command, the store procedure, to only return one row. Because if you did .first on the Dapper results, that's already on our machine. It's already in C#. Therefore, it's already transferred that data across the wire. The .first will give you just the first record, but you've transferred all that data. And so that's what you need to know there, is a Dapper command is going to pull down whatever you ask for. This is only going to pull down what you ask for in this entire query. You're in a query right here, essentially. This gets translated into this, all right, as hard as it is to read. Okay, so it is a good query, and it is pulling down just barely what we need. And that's a good thing. Now, I didn't really show you what it said, so let's go back and run that again. And this time I'll show you that, in fact, it does say Tim Corey. Okay, so it's reading 1. Now, let's do another create. Let's just create my wife as well. So we'll say create charity. We'll have some parity here with the rest of the apps. We're going to say nope at AOL. And she shares that one, but this one is 9876. Okay, so we will call this just once. We'll call this, so we have it. Let's run profile just to see what happens when we do that. So I'm going to start this, and then I'm going to run this. And once it's done, I'll stop it and stop this. And we'll see that we have a couple of executions here. The first, now notice there's 2 executions here. And the reason why is because we have to get back an ID of the contact record before we can then create the other records that use that ID. So this is the first entry. I'm going to copy this. I will paste it into a new query window, and we'll come back over here and get the other one. All right, we'll copy this and we will paste it down below. Okay, so here's the queries that it ran. So the first query is, again, set or sp execute SQL. Ugh, but it's fine. Set no count on, which returns one last piece of data, which is fine. Insert into context the first name and the last name, values of P0 and P1. And those values are P0 is Charity and P1 is Corey. And it's going to select the ID from contact where row count equals 1 and ID equals scope identity. It's going to make sure it gets the right ID value, and it's going to select that using scope identity. Now, what that's going to do is it's going to know what the ID is from the newly created record. Then it's going to use that in the next query. And this next query says merge on phone number using P7, P8, and 0. Inserted ID and the position. And then it takes that and does an inner join to reconcile it, it looks like. And it orders them. That way it can return those two IDs in the correct order that they were created. Okay? So it matches the ID to the right value. Because to return those two IDs. That's what the select ID is. And then here's the definitions. P2, 3, 4, 5, and what their size is. Now, interestingly, it says nvarchar 4000 for P3, which P3 is, let's find it up here. P3 is here is the email address is nvarchar 4000, which does not match up with what it can hold. It can hold an nvarchar max, which max is much larger than 4000, which means this query actually limits what our field can take, and that might be a problem if we actually pass more than 4,000 characters back. So there's our actual values that are mapped out. And this is the query that gets run. Now, this query set is much more complicated than what we would have written or what we did write for our SQL. Now, the difference is we wrote it manually versus C# writing it for us. However, where you find bugs like that might be a bug, or it might be an issue that causes a problem. I'm not sure, because I haven't tried passing more than 4,000 characters across my nvarchar max field. But it might be that it truncates the field. That might be a weird bug you don't find until production. At that point, you've got to figure out how to fix that. And you can't just go in here and rewrite the query because the query is that. Okay? So you're going to have to figure out how to get that to work or how to rewrite what this does. And like I said, they're doing some more advanced stuff with SQL here because the people who wrote this are incredibly smart. The problem is that people who aren't quite as smart like me have to maintain it. And that's where it can cause problems. So that's one of the hesitations I have using this is I have to debug this. If there's a problem, I have to come in here and figure out where the bug is in this code. And this is a simple one. Okay? You can imagine if it's not simple, how much larger this gets. Okay. So now we have our save. We've created 2 records. We've read all. We've read by 1. Let's do an update and a delete. So we will minimize these here. And let's have a private static void update first name. And we'll say ID and string first name. And we'll update the value of the first name of the ID we pass in. So using var db equals contact context, like so. Actually equals new contact context. And then in here, what we're going to do is we're going to modify a record. So let's first get that record. So var user equals db.contacts where db.contacts. Oops, I'm putting parens at the end of it. I shouldn't put parens. Where C arrow function c.id equals ID first, like so. Now we have the user. Now I can say user.firstname equals first name. Now we can say db.savechanges. Okay, I don't need to pass it back. It's going to know that I made a modification to the user, and therefore save changes is going to capture that. So let's call this up here. I'm going to modify my record. So I'm going to say update first name, and I'll say ID1 is now Timothy. Okay, and they can do a read all at the end so we know that we've actually made the change. I won't capture this in the profiler. There you go, Timothy Corey and Charity Corey. Cool. Now, let's do another modification. This time we'll remove a phone number. Public static void remove phone number. And we'll say from ID, and we'll pass in the phone number. Now remember, the phone number is actually going to be an object. But let's do the same thing as before. We'll start with the same or similar code. But we do have to include the phone numbers. And now contact ID is null. So what it did is said, hey, I'm going to break this link. That's all it did, is it broke the link, but it left the ID there. Not terribly ideal. Remember before we talked about the idea over in the migration? Let's go here. And we talked about, let's look down at, there we go, restrict. So this is the email address, this is the phone number. So restrict. So what this does is it says don't perform the action if it results in a constraint violation, instead to generate an error. But what it's doing, since this allows public static void remove user int ID. And we're going to have the same using statement like before, like so. And we're going to say var, let's say var users equals db.contacts.remove. And we're going to say which entity do I remove. Actually, let's go back and do remove all. Remove. Whoops, there's not a remove all here. It's remove and remove range. So we need to have an object, an entity to remove. We don't have one yet. Well, let's find one. So let's do this. Let's say var user equals db.contacts.where c arrow functions c.id equals id first. That gets the record. And then we can say db.contacts.remove that user. And finally db.save changes. Let's do that, and then let's read all. So I have read all up here. I'm going to say remove user, and then read all. I'm going to change remove user to be capital U, like so. And I don't know why I didn't change up here. It should have. Remove user. Okay, and it's yelling at me up here, and I'm not sure. I'm not passing in an ID. There we go. So I'm going to remove myself. So it should be that I just have just my wife left. Let's take out the remove phone number. Let's actually move that above like so. Okay. Let's run this. And it says, hey, an error occurs. See the inner exception. The delete statement conflicts with the reference constraint. Okay. So it's saying, I can't remove you because you've got email addresses still. That's when that constraint came in. Again, right down here where it says restrict. It's saying, no, you can't delete this record if you have links. And that's a good thing because we're saying, no, you can't just, let's stop this. You can't just remove somebody whenever you feel like it. You have to make sure that you're not going to leave behind orphan records. However, there is a way of doing this. Okay, so right now we just grab the contact, but remember down here we also include the phone numbers. Well, what if we did the same thing here? Include email addresses and include phone numbers. So you can kind of cascade those down and say, okay, here's the records to also remove. let's try this. Okay, so I'm going to change this. I did test this before I ran it, so I'm going to change my ID to the correct ID, and we're going to run this. And it's going to say just Charity Corey now. It's deleted those records. Okay? Okay, so now we've figured out how to remove. That's cool, but we still have some database issues. In fact, we have quite a few database issues. So if we come over here and look at our database, we have the issue of this is an nvarchar max. That's not right. We want this to be a varchar 20. And the email address, we want it to be a varchar 100. And the first and last name, we want to be nvarchar 100s. How do we fix all this? How do you fix the fact that this is nullable? We don't want nullable. Okay? So let's fix these things. So we're going to go over to let's start with contact. So let's make the first name be a max length of 50. So we can say max length. We have to do control dot here to add the using for system.componentModel.data annotations. Then we can say 50. And let's also make it not nullable. So required. All right, these are decorators. We're going to do the same thing for last name. Now these two are required and they have a max length of 50. Let's go over to email and say the email, this is required. Control dot here to add that using statement. But it's also a varchar 100. Well, how do you make it varchar? Well, you say column, control dot add a using for system.componentModel.data annotation.schema. And then you say type name equals varchar 100. Okay, this is going to define this as a varchar instead of nvarchar in SQL. Now, this is going to be different if you're using SQLite or MySQL because they might handle things a little bit differently. So be careful, this is not code you can then swap out for a different database type. Also, with the contact table, this is going to respect this max length when we are working with it in C#. It's not going to allow more than 50 characters. I do not believe that it respects this max length of 100. I believe we have to come here and say max length of 100 in order to get that for the C# side of things. Okay? Now, we also have the idea that this email links to the contact table, the contact ID. That's not in here. Well, we can specify it. Contact ID. And this is mapping by name essentially. And now we can say this is required. Okay? And then phone number. Well, that's going to have contact ID. That's required. Control dot to add the using. And then just like email address, this is going to be limited, but this one's going to limit it a little bit different. First of all, it's required. And then it's going to be a column. Add the using statement. And then it's going to be type name equal to varchar of 20. So max length of 20 for our phone number. Okay? And if we want to do the required here, so max length is 20. Oops, not 2, 20. There we go. So now I've made some modifications to our models in order to better design our database. Now we need to create a new migration. So back to Package Management Console, come down here to the end and say add migration and give it a name. This is improved columns. Let's call it that. That's the migration. And it says, gives us yellow bar, which is really helpful. An operation was scaffolded that may result in data loss. Please review the migration for accuracy. Because we have limited columns to be shorter than they used to be. We've also said that things are not nullable when they were nullable, which means that there's some data in here that won't work anymore because it's null. So that's going to be a problem. Well, now we say update database. And it's going to apply those migrations, and it says cannot insert the value null into column contact ID. Column does not allow nulls, update fails, statement has been terminated. Now we've got a problem because we have data that is invalid. Okay, so if we go over to SQL, let's pull this up and let's look at our phone numbers. We have 4 values now that are null. Okay, now email addresses, I believe, oh no, email address as well. And contacts, I don't believe we have any null here. We do not. So what we need to do, we need to actually clean up our data manually. Let's add the top 200 rows. Let's delete these 2. Yes, we want to delete them. Delete these 2. Yes, we want to delete them. And then edit the top 200 rows here and get rid of these as well. And these as well. Okay. Now we've cleaned up our data. I believe we should be able to do our update. This is where things get a little messier. You have to understand how your server works, and you have to realize that it's a little, you gotta be very careful to up front plan your database correctly. So now that this is done, let's go over and let's close these out. And let's refresh the table list. And let's look at contact columns. We've got a first name of nvarchar50, not null. Last name of nvarchar50, not null. We have an email address that's varchar100 and not null, and a contact ID that's not null. Phone number, same thing. Phone number is varchar20, not null, and contact ID is not null as well. So now we have a database that's a little better structured for what we want designed. But notice now over here, we also have multiple migrations. So we have even more code to review and maintain to make sure that this code is correct. Okay, so to review this code, make sure after the whole query. Sometimes you want the query at a higher level to have more information from the user interface. That's not a great idea. So what you really want to do is you really want to map these things out, and you want to push them down into your data access layer, and then just call this remove user, which calls down into your class library and talks to entity framework. So that's where entity framework encourages that move up the chain closer and closer to UI, really push that back down and plan out your application to put this into a class library, not directly into your user interface. You'll have much better success then. Okay, so let's look at our tip for today, which is to be sure to watch your warnings and test the speed of your entity framework code. Okay, so make sure you're looking for any of those warnings that pop up. Hey, this is a problem, that's a problem. One of the things that we didn't do, but that now has a really nice warning, is if we go back here to our where clause, if you were to wrap this in a method, okay, a C# method, you could do that. But think through how that would work. Because right now, this whole query is passed up to SQL, and we only return one record. But if we, in the where clause, run a C# method, we have to have all of the rows in the contact table to run against that C# method, which means that we pull all the data down, then run in the where, then get the So your homework is to build a simple application or simple database using Code First Entity Framework. Create the models for people, addresses, and employers. Make sure it builds, and then you can download or you can load and save data. Just try it out. Try figuring it out. Also try putting it in a class library, see how that works, and make sure you put your code in a different layer from your user interface. Don't just put the two together. Okay? So that's your homework. And that's just about it for this course. In the next lesson, we're going to kind of wrap up what we've learned and see where we go from here.